Now let's write the Java based code for jump searching algorithm. Let's create a new class called jump searching, and let's add the main method and let's click on finish. Okay, here let's define a function called public static int, and let's define the function name as jump searching, and it will take integer array of ARR and a value that user wants to search. Okay, so as part of the first step, what exactly we did, we will basically define the block size. So int block size equal to math dot sq square root of array dot length. Okay, this square root operation can give some floating point values after the digit, right? So to eliminate that, because we want indexes that are whole numbers in the array, for that what we will do, we will simply do math dot floor of square root, and math dot floor's return type is double, that is it will remove all the floating point values and it will put 6.00 something like that. So to remove those also, we will simply be typecasting it into integer. Okay, once we have the block size, the last index in the block size will be block size minus 1. Okay, what exactly we did after getting the block size, while this last index is less than length of the array, which is nothing but array dot length, and the value at this last index, that is last index, is less than the value that user has given. Then what we will do, we will move on to the next block's last index. How we will get that? Next block's last index will be current last index plus we will simply add the block size to it. Okay, once this is done, we would have reached a position where this last index will hold the the block's last index for the valid actual block. So we need to simply do, we can simply perform either binary search or linear search. Here I will be writing the logic for simply linear search. So the starting point for the block would be, let's say int I will start from index minus block size plus 1. This will be the starting points, because at this point, once we complete this loop, the last index variable will be pointing to the valid block's last position. Okay, to go to the starting point of that specific block of the array, this is how we will get the starting position. And what we need to do, this I is always less than or equal to last index. And one more thing, you have to make sure that I is not going beyond the length of the array, that is arr dot length. And in each and every step, I want to go on to the next step, next index. Here in the linear searching algorithm, what we will do, we will simply, if array value at ith index, if it is matching with the value that user has given, we will simply return index, which is nothing but I. Okay, once this for loop is executed, we would have searched all the possible indexes in that specific block. If the value is not available in that specific block, we should simply return minus 1. Okay, make sure that whenever you are running this loop, you are making use of this last index variable. If you don't make use of this last index variable, there is a possibility that you will go ahead and search in the entire array as well, which is a bad thing, because that is the purpose of this jump searching algorithm, because we are trying to find the block size which we want to restrict in our searching. So this is done, right? So, and one more thing that I would say is, since I'm using linear searching here, you can go ahead and you can implement your own binary searching based implementation as well. So let me just pass on some values and see if it is actually working. And jump searching requires all sorted values, right? So I've created sorted values, and let's say the value that I want to search is, let's say it is, let's say 4, And now what I will do, I'll simply call the jump searching algorithm. I'll pass the array and I'll pass the value, and it will return the index, right? Let me store it in index variable. Let's just print it so that we can validate the result. Now let's just right click on it and run as Java application. Okay, if you see it, index 3 contains the output that we have got is 3, and the index 3 contains the value 4. Let's say the value that I want to find is 7. Now if I run it, I should get index 6. Okay, because index 6 has value 7. If I run for the value 17, I should get -1 because the value is not present in the array. Similarly, if I pass any lesser value, also I should get -1. Okay, this is how we actually implement the jump searching algorithm. Okay, I hope you are also able to implement it. I'll see you in the next one.